Hey everybody, thanks for checking into another math video here. This one is about rationalizing denominators with a conjugate. And in case you don't know what a conjugate is, I'll explain that in just a second. But first, I want to remind you of something that you probably already know. In the study and practice of algebra, we frequently see binomials like x minus 1 or 3x minus y squared. And you have learned, I'm hoping, how to perform different kinds of operations on them. And for this video, what I'd like you to do is recall one of those operations, which is a special case of multiplying two binomials that are in the form a plus b times a minus b. That's really at the heart of this little process that I'm showing you today called rationalizing the denominator with a conjugate. Now, first, those two binomials are called conjugates. A plus b and a minus b are called conjugates of one another. They have the same first term and opposite second term. That's what makes them a conjugate. All right? Now, maybe you've already done that little multiplication in your head, and you will recall that a special thing does happen when you multiply two conjugates together. What you get is a difference of perfect squares. In other words, a plus b times a minus b equals a squared minus b squared. All right, that's right there at the heart of this process. All right, this is a number trick I'm showing you. It's a process on how to simplify a certain kind of fraction. All right, and we're going to take advantage of this property here when we are trying to simplify certain kinds of fractions with irrational denominators, specifically fractions with irrational binomial denominators. Fractions like this, 1 over 1 plus the square root of 2. Or maybe it's a more purely algebraic expression, like x over 2x minus the square root of x. Again, those are denominators that are in a binomial form, and they have an irrational part. Or maybe everything in the denominator is irrational, but any fraction that has an irrational binomial denominator, boy, we're really stacking up the math words today, aren't we? You can use this process that I'm going to show you in this video with this. Actually, you can use it on other kinds of fractions as well, like ones that have a complex denominator. This process that I'm showing you will work with those fractions as well, but I'm not going to really discuss any examples like that in this video. Alrighty? Okay, so here's the principle. As succinctly and clearly and as simple as I can make it, what you're going to do is multiply the fraction that you have by another fraction equaling 1, and that fraction will be composed of the conjugate of the denominator over itself. Now, I know that's, again, a lot of heavy math language there. So rather than parse it out too much, let's just kind of demonstrate how this works. Alrighty? Here's an example that we can use to practice this first. 1 over 1 plus the square root of 2. So our denominator is an irrational binomial in the form a plus b. So the conjugate of that denominator, the one that in the a minus b form, would be 1 minus the square root of 2 over itself. Okay, so that fraction there, that fraction equals 1. It's very important right at the core of this process, because I don't want to change the value of that fraction that I'm starting with. I just want to change how it looks. So if I multiply it by 1, I'm not changing the value. But as you will see, it will change how it looks. All right? So a plus b times a minus b is a squared minus b squared. All right, so what does that look like for our fraction here? 1 squared minus the square root of 2 squared. That's what it'll look like on the bottom. Now you see that when you take the square root of 2 and square it, you just get 2. So it's no longer irrational. So what we're doing is we're making the binomial in the bottom of this fraction here, 1 over 1 plus root 2, we're making it a rational number. All right. Now the top is just 1 times 1 minus the square root of 2. So that's how that goes, 1 minus root 2 on top. But our denominator here, this is where kind of the cool thing happens. 1 minus square root of 2 squared, well, that's just 1 minus 2, and that's just negative 1. So now we have 1 minus root 2 over negative 1. And that's just going to change the sign of the two terms on top. So you get negative 1 plus the square root of 2. And I think that probably most people, and when you look at where we started and where we ended, that was a big improvement. They're the same number. They're just two different expressions of that same number. All right? And this is what we're learning here. We're learning that there are many different ways to write numbers, and we are learning different expressions for those numbers. It's part of our number fluency here that we're building up. Okay, let's try another example. It's a little bit more complicated. 3 root 2 over 6 minus 2 root 2. Okay, so now our denominator is kind of an a minus b form. So the a plus b conjugate of that, 6 plus 2 root 2 over itself. Okay, again, the fraction that we're using is just a fancy form of 1. So we're not changing the value, but we are going to change how it looks. All right, let's start multiplying here. That a squared minus b squared part of the denominator there, think about that. 6 squared is 36, and I'm going to let you verify for yourself that 2 root 2 squared equals 8. All right? You make sure that you verify for yourself that that is the case, in fact. All right, now let's multiply the top using the distributive property now there. That's going to give me 18 root 2 plus 12. Once again, please verify for yourself that 3 root 2 times 2 root 2 does, in fact, equal 12. All right, so let's simplify a little bit more. 36 minus 8, that's 28 on the bottom. And I've gone ahead and factored out a 6 from those two terms on the top to give us 6 times 3 root 2 plus 2. All right, and I did that because I'm noticing that everything is an even number, and I can reduce everything in the fraction by a factor of 2. All right, so I get 3 times 3 root 2 plus 2 over 14, and I'm thinking, well, there's not really much reason to have that numerator factorized out like that, so I'll just multiply and get 9 root 2 plus 6 over 14. This is my final answer. Is that better? I think so, a little bit. It's not, it's still kind of a hairy looking fraction, but at least there's only one irrational number in it, and the denominator is completely rational. So I think it's better, I guess. All right, let's do one more. This one's definitely more complicated. We have a binomial on the top and the bottom of this fraction. And let's figure out what our conjugate is going to be. That'll be 3 plus root 3 over itself. Okay, there's our fancy form of 1 that we're multiplying. So let's start doing it here. 3 squared plus root 3 squared. That's not going to be too much trouble on the bottom. But the top, is 2 binomials multiplying together. So we got a little bit of work here. 12 times 3, 12 times root 3. Actually, that wasn't so bad. Then we got 2 root 3 times 3 and 2 root 3 times root 3. Boy, kind of a mess there. But there we go. There's our numerator all multiplied out there. And now let's see if we can combine some like terms and simplify some more stuff. That's nice. On the bottom, we just get 9 minus 3. That's 6. When we start combining like terms on the top, we'll get 36 plus 6 is 42. 12 root 3 plus 6 root 3 is 18 root 3. Nice. Everything can be divided by a factor of 6. So we end up with just 7 plus 3 root 3. Not bad. I'd say that's definitely an improvement over what we started with. Now we don't even have a fraction, and there's just one irrational part about that. And kind of surprisingly, we end up with a 7. Who would have thought that from looking at that first fraction there? Okay? All right, so that was a couple of examples there. I just wanted to kind of summarize here a little bit what we're doing. First off, defining that term there, conjugate. Binomials in the form a plus b and a minus b are called conjugates of another. Once again, it's the same first number and opposite second number is what makes them conjugates. All right? Now, in some cases, to rationalize some kinds of fractions denominators, what you do is you multiply the fraction by another fraction equaling 1, a fancy form of 1. All right? And that fraction is composed of the conjugate of the denominator over itself. All right? And I know that's heavy language there. It's kind of thick, but it was the simplest way that I could think of to describe this process and try it in kind of a one-sentence description. So I hope that works for you. Please watch the video again if you like. Be well, do some good math, and I hope I see you soon. All right. Thanks again very much for watching. Bye-bye.